Assalamualaikum everyone. Before this, we have learned about thin lenses, how to sketch the ray diagrams. Now let's go to the equation. For lens, we have three equations. First, lens maker equation, thin lens equation, and also linear magnification. So what is lens maker equation? Lens manufacturer use this equation to produce varieties of lens with different focal length. So why does professional photographer have so many types of lens? Because each lens has different focal length, different radius of curvature, different type of material, and each lens is being used for different purpose. Different lens has different price. They can cost from 100 to even 10,000 of ringgit for one lens. Well, it's not that easy to produce a lens. Let's look at this simple ray diagram to show how does refraction occur at both surface of this thin lens. O is the object and the incident ray will come from the object and then refract at the first surface. So R1 is the radius of curvature for this first surface. And R1 is always the first surface that you see. So this will be R1. Radius of curvature for the first surface. And then when the light ray refracted from the first surface, it will produce the first image. And we label it as I prime. It's up to you. You nak label dengan simbol apa pun, must show that this is the first image. Okay, why do we say this is the first image? Because this is the image produced by the first surface, which is R1. The refraction from the first surface or R1 will produce the first image. After that, this image will become the second object. After that, this second object will produce incident ray from here and then refracted at second surface or R2, and the refracted ray will produce final image. So kalau for the refraction at spherical surface, kita cuma ada satu saja spherical surface, so the image akan terhasil satu saja. But when it comes to thin lens, there are two surface, ada dua R, so the image will produce twice. Okay, so dia akan menghasilkan satu image dahulu, image pertama, kemudian image pertama tu dia akan jadi objek yang kedua. Selepas itu, dia akan menghasilkan final image. And then look at the refractive index. If the thin lens is being placed in air, okay, so N1 is air, N2 is the medium of this thin lens, and then N1 ni air balik lah. Okay, from this ray diagram, there are derivation until we get this lens maker equation. So there are two methods for this equation. The first one is 1 over F equal to, in bracket, N2 over N1 minus 1, close the bracket, times with, in bracket, 1 over R1 plus 1 over R2. So 1 over F. F is the focal length of the thin lens. Walaupun dia ada dua R, R1 and R2, but it will only have one focal length. So how to find the focal length? By using this lens maker equation. So as usual, N2 is the refractive index of medium 2 or medium that contain the refracted ray. N1 is the medium that contain the incident ray. R1 and R2. R1 is the radius of curvature for the first surface, and R2 is the radius of curvature for the second surface. For example, if I have this kind of lens, or this one, so this, it will be the R1, R2, and then this one will be R1, R2. The first surface will be R1 and the second surface will be R2. So for the sign convention, we need to focus on the sign for radius R. Okay, so before you substitute the value of the R, we need to check whether the surface is convex or concave. So if it's convex, it will be positive, and if it's concave surface, it will be negative. But for this equation, there are methods how to determine which kind of surface is convex or concave. So this is the example. How do we determine the sign of R1 and R2? Macam mana kita nak tahu R1 ni convex surface ataupun concave surface? Okay, for this method, we need to look from both sides. Awak kena tengok daripada dua arah. So we are going to look at from this side. If you look from here, from your view, this surface is convex. Dia cembung ke arah mata awak. So R1 will be positive. And then for the second surface, we look from this side. Okay, this surface is concave. Dia cekung from your eyes. So the value for R2 is negative. So if you want to use method 1, okay, which is this equation, you need to determine positive and negative of R by using this method. Look from both sides. So let's look at different types of lens and how do we determine the sign of R. The first one is by convex. If you look from here, the surface is convex, so positive. And R2, when you look from here, the surface is convex also. So both are positive. For this one, when you look from this side, it's concave, so it's positive. And for this side, since it's flat, plane surface, it will be infinity. How do we use infinity? So 1 over infinity is also equal to 0. So nanti dalam equation just substitute infinity. And then 1 over infinity will be equal to 0. For the converge meniscus, if we look from this side, it's convex, so positive. And for R2, we look from this side, it will be concave surface, so negative. Next, for concave or diverging lens, first we look from this side, it's concave, so it's negative. Then for second surface, we look from this side, it's also concave from your eyes, so it will be negative. Plano concave, when we look from this side, it's concave, so it will be negative. And this one is flat, so it will be infinity. For diverged meniscus, when we look from this side, it's convex to your eyes. And when you look from this side, it will be concave to your eyes. So it depends on the shape of the lens. It's either when you look from that side, is it concave or convex surface? It will determine whether positive or negative. For method 2, this method can only be used if N1 is less than N2. For example, if we put a lens in air. So air is 1.0. Lens, for example, glass 1.52. So N1 is less than N2. What if I put this lens inside a medium that N equal to 3.0, for example? So you can't use this equation. Please make sure that if N1 is less than N2, then you can use this equation. What is the difference of method 1 and method 2? First, the difference is in the equation. Look at this one. For method 1, it should be positive, but for method 2, it's negative. Okay? Macam mana pula boleh jadi negative? It's because of the radius R. So untuk method 2, we are going to look at the surface from one side only, which is our left side only. Okay? So if the surface is convex, it will be positive. If the surface is concave, then it will be negative. Alright, so look at this example. Since we are going to look at from our left side only, so once we look at the first surface, it's convex to your eyes, so it's positive. R1 is positive. For the second surface, we are going to look at the same, we are going to look from the same side, which is from here. Look at the second surface, so it's also convex to your eyes. Then it will be positive. So both R1 and R2 will be positive for this lens. Let's look at the other example. For this one, okay, so your eyes will be here. When you look at the first surface for biconvex, it's convex to your eyes, so it's positive. And then for the second surface, when you look at the second surface from this side, it will be concave to your eyes, so it's negative. For the planar convex, you look from this side. Okay, for the first surface, it's convex to your eyes, so it will be positive. For the second surface, it's flat, so it will be infinity. For For the convex meniscus, when you look at the first surface, it's convex to your eye, so it's positive. And for the second surface, it's also convex to your eyes at this side, so it will be positive. For biconcave, okay, so we are look from this side. The first surface is convex to your eyes, it's negative. And the second surface is positive because it's concave to your eyes. Permukaan ni dia cembung ke arah mata awak yang melihat daripada arah ini. Next, for planar concave, for the first surface is concave to your eye, so negative, and second surface is infinity because plane surface. And then divergent meniscus, this side is convex, so positive R1, and this side is convex also, so it will be positive R2. So it's up to you which method that you want to use, but for example, I will use method 1 first. Alright, next equation is thin lens equation. So thin lens equation is the same with the spherical mirror equation. 1 over f equal to 1 over u plus 1 over v. But the differences is at the v. For v, if v is positive, it's real image. But the image will form opposite side with the object. Okay, so if, for example, we have this convex lens, if the object is here and v is positive, so image will form opposite side with the object, which is here because v is positive, or we can say that the image is real. But if v is negative, so negative v means virtual image, image will form same side with the object. So if the, let's say here, the image, let's say the image from here, because v is negative or virtual image. So when we calculate v using this equation, if you get v positive, then we know that image is real and form opposite side with the object. If the value of v is negative, then we will know that image is virtual and form same side with the object. Second is, if focal length positive, then the lens is convex lens. If the focal length is negative, then the lens is concave. So dia terbalik dengan spherical mirror equation. Kalau mirror positive adalah concave mirror, negative is convex mirror. But for lens, thin lens equation, positive value of focal length is convex lens and negative value of f is concave lens. The third equation is linear magnification, M. So this one is the same like what we have learned in mirror.